Welcome everybody to week 5, I believe. We're on week 5 now. Week 5, day 3. I think last time I said week 4. How time flies. So yeah, this is one of my favorite Inca songs. She jams on the shamisen, and there's a couple guys jamming with her. Some of you were posting trolley memes. There's been some pretty good trolley memes posted. There's a whole subgenre of memes that are just trolley problem memes, and that's kind of what we're talking about with the autonomous vehicles project, Stanford Cars Lab. I told you I'd tell you what they said. So I was here. I took my students actually. We went on a field trip, and Stanford was actually very nice to us, and I think like the dean of like one of the colleges showed us around, and it was a pretty fun time a few years back. And we checked out the autonomous vehicles here as they're programming them. They program like race cars to drive without a driver and stuff like that. And so I asked the guy who was the head of the center, like, what's your solution to the trolley problem? And he said it was based on the quizzes. Yeah, that's the thing. Like, my suspicion is that like all these moral machine quizzes are used to kind of, if not program machines, because that'd be dangerous. You don't want to program machines that could kill people based on internet polls, right? That's how you get Bodie McBoatface and the absolutely horrible results of the Mountain Dew flavor poll. I'm not going to tell you what those answers were, but Mountain Dew did do a survey where they asked people for the name of a new flavor of Mountain Dew, and they were horrendous. Yeah, you don't want to have people on the internet programming your autonomous vehicles. But my suspicion is that the Moral Machine Project is going to be used to just sort of get a sense for like where people's opinions lie, and then you can kind of use that to sort of calibrate your machine, right? And it's not like a car is not going to know this person's rich, this person's homeless, between a cat, a dog, and a person, sure, male or female, yeah, young person, old person, it's a little dubious, especially when you're coming at them at 60 miles an hour, like, it's probably, I don't know, probably not going to happen, maybe, who knows, but, my guess is they're going to kind of just use those results to just see if, like, the way they program their machines are sort of in the ballpark of what the community thinks. And so, the director of Stanford, when asked him that question, first he didn't know what I was talking about, which was interesting. He's like, the what? I'm like, the trolley problem. There's like a trolley, and you have the lever and the thing, and with autonomous vehicles, at some point, a machine is going to have to choose between killing two different people, right? It's going to happen. And he's like, oh, yeah, I know what you're saying. Yeah, so what we're going to do is we're going to do a simulation, and we're going to put undergraduates into a car, and then we're going to put them in a situation where they have to drive over one person or another, like a dog versus a person or whatever, and then we're just going to write down who they ran over and then program the machine that way. Oh, I should mention simulation, right? Did I say simulation? They're not actually driving over people. I hope I made that clear, because I'm not sure I said simulation. So, yeah, they have a simulator there, and I saw it, and his answer was like, basically, we're going to punt. Like, we're not going to try and solve this weighty ethical dilemma. Instead, we're just going to let humans do it, and then we're just going to take whatever they do and just like put that in ours, and then we can wash our hands of the, like, he didn't say we're going to wash our hands of the whole thing, but that's kind of the takeaway was that, like, they just like were like, we don't want to choose who's going to die. We will offload that to unnamed college freshmen, who will then choose who dies. And I'm not sure. Like, I get why you would do that, right? Because like, can't blame us. It was the college freshmen. You sue them. Who? I don't know. We don't have their names anymore. So I get the strategic reason for doing that. And it makes a certain amount of sense, too. Like, just, all right, run over who people would run over. Then you can't blame the autonomous vehicle for anything, because it's the same person that a person would run over. I get it, But at the same time, like, it seems like very, not very deliberate. about trying to answer the problem. It was just like, yeah, we just don't want to go there. Like, let's just not talk about killing people at all. Let's just not think about it. And that kind of runs counter to my whole thesis for this class. Is like, you need to think about these things. Like, at some point, an autonomous vehicle is going to run over somebody, and it has happened already. A person stepped out in front of a Tesla at 60 miles an hour and got splattered, right, in Phoenix. It's already happened. And, sure, you don't have their name anymore. Yeah, who knows, we threw all the records away, So, it's like, is that a good thing to, like, just have the computer just sort of randomly kill people? Like, I would argue no. I would say it's better to have some sort of ethical system in place, like 2 people versus 1 person, you know what I mean? Or just like never change lanes. I mean, that's actually a fairly reasonable algorithm, as long as, change lanes if you can avoid a collision, but if you're gonna either run over people or go into opposing traffic and die, like, just stay in your lane and hit the brakes and hope for the best. And a lot of autonomous vehicles avoid accidents by just driving really, really slowly. You ever seen the autonomous Google vehicles in the Bay Area? They drive at a snail's pace. And so while they might not be getting to accidents, they might be causing accidents by people going around them because they drive super slow. Because if you drive really slow and somebody steps in front of the car, you just hit the brakes and it stops. Braking distance increases a lot the more quickly you're traveling. So if you just travel really, really slow, then, you brake and you just come to a stop, So. How bad is the traffic in the Bay Area? Oh, sweet summer child. Lord. Arguably the worst in the nation. Now, Google is based out of Mountain View, which is south of San Francisco. The traffic in Mountain View is not bad. I have a friend that lives there, and I visit. Well, before the pandemic, I visited quite regularly. It's not terrible. It's like driving around in the suburbs here in Fresno. Like, you're not going fast anyway. But any of the areas where you could be going fast, like in the 101 or the 280, I think the machines don't even go on them. So I think they just stick to residential 25-mile-an-hour zones, and then they drive like super slow on top of that. So traffic anywhere is bad. LA, San Diego, Bay Area. What do you mean where, Ashley? Mountain View? It's we did a tour to here as well. Let's see, not to the Googleplex. There's the 101. Where am I? Computer History Museum. Yeah. So Computer History Museum is awesome. Go there if you get a chance. And so let's see. There's San Antonio. Let's see. There's Rungstorf and Bayshores. Shoreline. Yeah. So my friend lived right around here. There's Moffett. Yeah. So yeah, spent a long time. I've spent a lot of time in this area. It's quite nice. It's like if you want to see what it looks like, it's just just this kind of stuff. So anyway, so that was the official solution, is just offload it to freshmen. Okay. Oh, you're on the car yet? I'm trying to follow. Yeah. Oh, I'm sorry. It's San Francisco Bay Area. It's on the peninsula south of San Francisco. The whole San Francisco Bay Area has just garbage traffic. San Francisco's probably the worst bit of it, but the entire 101, which is the east north-south artery, is just miserably bad. The 280 is better, which is why when I lived there, I chose to live on the 280, specifically because I liked being able to not be stuck in a parking lot on the freeway. Yeah, they put a real world problem on freshmen. Yeah, I mean, if you really want to think about it, most of psychology is based on college freshmen. right? All these studies that come out, like America has a problem with binge drinking and wild, reckless, promiscuous sex. And you look at the study, and it's like, we surveyed 100 college freshmen in their first week of college, and it's like, okay. Like, you know, it's because, like, when you take a psych class, you have to participate in studies. So I've been going through some of your answers here, and I think you guys did a pretty good job overall. Okay, so we're going to talk about programming today. That's the big topic for today. I've had some questions about the midterm, which will be next Friday. The format for that, and we'll review it like on next week, but on Wednesday. But for those of you that want to start prepping for it, look at the old quiz questions. If any of them are locked or you can't see the answers, I can unlock the answers for them so you can see the answers. The midterm's basically going to be those in midterm format. So that's it. The midterm will be available for the whole window from Friday to Monday. So Friday after class gets out, because I don't want people taking the midterm during class. That would be silly. So what would that be? 11 o'clock next Friday, the window opens. The window closes the following Monday at 10 o'clock sharp. Okay? Once you start the test, you have an hour to take it. And it'll be like 20-ish questions, something like that. So you'll have about five minutes per question. If I do anything that would involve like Googling, like, is it true that, the U.S. government tested biological weapons over the Bay Area in the 1950s or 60s? Like if it's something like that, which was true, by the way, if I do something like that, then I would give you more time. Okay, so it said 50 for 2 hours. Okay, so yeah, so 50 questions, 2 hours. I don't know. It'll be something like that. Okay, but basically, you can choose to start the midterm whenever you want, and then when you take it, there's a window, and then you can schedule it whenever you want during that time period. Just don't wait until like 9:50 on Monday morning to start it, thinking that you'll get the full 2 hours, because you won't. It's a hard cutoff at 10 a.m. because I go over the midterm then. Okay, one of my friends took my class and thought he would pull a sneaky and start the class final like a minute before the hard deadline, thinking he would get an extra 2 hours, and he didn't. That was funny. Okay, I wonder if he's in here right now. No, he's not in here right now. Yeah. Okay, we'll just be on Canvas. Yeah, just on Canvas. So just like the quizzes, you just click on multiple choice stuff. No tricky Googling, please. Okay, well, I haven't decided yet how mean I want to be. So you'll have an hour to do 20 questions, something like that, or basically when I write the questions and I kind of eyeball it, be like, all right, this might require a little bit more time. So I try to be pretty generous with time, because teachers like grossly underestimate how much time it takes to solve a question for a student. Like I was taking my Japanese class this last semester, and we had 10 minutes to answer 10 questions. And so there'd just be a question in Japanese, and then there's 4 answers. And I have to sit there and 10 questions, so you have a minute. And so I have to read the question, which is in Japanese, and decipher it. And then I have to decipher each one of the 4 multiple choice questions, and I'm not that fast, And it was brutal. Like I kept like getting like 7 questions and 8 questions in and running out of time, So it's just so stressful. So stressful. But she allowed us to retake it. So I'm like, okay, I'll just take it again. I'll just mentally write down the answers. But then there were different questions the next time. I'm like, no. She allowed us to retake it 5 times. But each time it was just like, So, okay. So yeah. It was pretty hardcore. All right, so let's talk about program. So that's the midterm. We'll talk more about it next week. If you want to prep for it, just look at the quiz questions. That's how I put my midterms together. I don't like surprise you with like, new stuff or whatever. It's all the stuff we've talked about this semester so far, and the quiz questions will give you an idea of what the questions will look like. Okay. All right. All right, so we are going to be doing what's called Scratch in this class. By the end of the semester, depending on if you guys like Scratch or not, we might move on to a real programming language called Python. Scratch, though, is designed for like K-12 students, and I mean that literally at like K, you can have kindergartners programming in it. So, you know, don't be too offended, I guess. My daughter took a class in Scratch this last summer, and she was in between 3rd and 4th grade, you know, so yeah, this is, like I told you, CSI 1 is like the most basic, gentle introduction to programming you can do. But, it's all pretty and graphical and things like that. So, but you can still do pretty interesting things in Scratch. Will there be a true or false question regarding if you bought $3,000 worth of hair? I might have to put that one on. I don't know. I'll think about it. So we don't do anything with the peer reviews. You've been given peer reviews. The assignment for Moral Machine explains what you should do with those peer reviews. So go ahead and read that if you haven't. Okay. So yeah, Scratch. Okay. So in computer science, there's only 6 things you can do in all of computer science, and we're gonna learn how to do all of them today in Scratch. Okay. I'm gonna teach you the entirety of computer science in Scratch in the next half hour. Okay. So. If you were to take CSI 40, they would give you an entire semester for this. But you guys are smart, so you're gonna get an entire semester's worth of computer science in one class. Okay, the 6 things in computer science. Make a variable. For example, you've all taken algebra, right? I hope. X is equal to 10. X is equal to x plus 10, that kind of stuff. And in computer science, like in algebra, this wouldn't make any sense, right? But what this is saying is like set the value of x to be, you know, the value of x plus 10. Okay. So make a variable. You guys all took algebra, right? Please confirm for me. If not, we'll have to seriously reconsider stuff, or life decisions and stuff. Okay, good. So you don't have to know, like, I don't know, the advanced algebra stuff, just like what a variable is, you know, and that kind of stuff. All right, whenever the peer responses due, there's no due date on them. Okay, so if you want to do them by like Monday. It's optional. Okay, make a variable. Okay, so make a variable, and then there is input and output. For example, the mouse is clicked. Print. You win. To the screen. So there's different kinds of input and output. Clicking a mouse, hitting a key, you know. There's a lot of different ways of doing input and output. Okay. Playing a sound of farting. Remember, this is written for elementary school kids. Input and output, make a variable. Okay. What we call conditionals. If health is less than or equal to 0, then print you dead. Else print you live. That kind of stuff. Sound of farting with reverb. Whenever I teach my CSI 40 students how to make a beeping sound on the computer, I just have to like stop, because immediately everybody like starts beeping the computer over and over again. Beep, 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 and I just like have to wait for everybody to literally the same thing. Like when I learned that when I was a kid, you know, how to make the computer beep. First thing I did, make the computer beep. Infinite loop, make the computer beep. Beep, 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 beep. Okay. Conditionals. A conditional means do one thing or another, right? This is where all of the intelligence in a program comes in. You know, if the face recognized is Kearney, then shoot a ping pong ball at him. Otherwise, don't. Right? Loops. Beep an infinite number of times. 10 times. 3 times. Ask for a password. Yeah, that kind of stuff. Will we learn to print hello world today? I mean, that's the traditional first program, but I mean, some of my fellow professors think that it's too boring for students. I don't know. Do you guys want to learn how to do hello world in Scratch? We can do that. It's tradition. Okay. This is the way? Fine. Okay, so functions are like an algebra, right? If you remember in algebra, you can have f of x is equal to 2 times x or something like that. So functions are like reusable bits of code. And yeah, that's about it. We don't even need to worry about the sixth thing. So that's basically all of computer science. You can do all of computer science just with this. When you get to graduate school, there's not like some mysterious seventh thing that you learn. You basically learn all of it today, and you will. So, yeah. If you don't laugh, you're too serious. Okay. All right. Anything you reuse too much, it is obviously annoying. Yeah. Okay. So we're going to learn all this stuff today. And basically, once you know all this stuff, you can write any program technically. Now, the reason why first semester computer science students don't write, you know, World of Warcraft from scratch, in Scratch, is because it's very big and complicated. And so the actual hard part of computer science is like structuring your brain to be able to write bigger and bigger programs. But these are the tools. And so once you master the tools, then all that remains is practicing. Okay. So let's go through this. So here we have Scratch. I'm going to minimize my face and take it off the recording as well. Okay. And so here we have Scratch. So let me explain to you how Scratch works. This is the actual output of the program. Right now we've got this cat thing. We can move it around if we want. We've got a little green flag here that means run the program, and we got a little red thing that means stop the program. Okay. And does capitalization matter in coding? Yeah, it does. Yeah. So this is very similar to a program we did in elementary school called Hour of Code. Yeah, Scratch is, this block programming is used a lot in Hour of Code as well. Okay, so you can, there's a couple different ways you can kind of start programming this. The first is like you can make it when like the dude here is clicked, but I'm just going to do it the traditional way. And over here on the left, you have a palette. You have a, it's like all the different things you can do are like over here. And in fact, you can just scroll through all of them. And this is literally everything you can do in Scratch by default. And the starting point is usually going to be when the green flag is clicked. Okay. So when the green flag is clicked, what do you want to do? Can you make your own animation? Oh yeah, absolutely. Okay, so we had a request for Hello World. So basically what I'm going to do, watch this. This is how you program in Scratch. Is that you drag out a block, and you see how there's like a little indentation on the thing that matches that one? When you get close to it, you see how it like turns gray? That means it's going to snap into place. Okay, and so what you do is you just snap it in place like that. And there you go, you've got a program. So, let me hide my face again. When I click the green flag, Scratch says hello for 2 seconds. Okay? So, that's the there's your first perm. Hello world. You know. Hello world. So when we hit the green flag, it prints hello world for 2 seconds. And there you go. You're welcome. So it is easy. You know, a lot of people are afraid of programming because when they see programming in Hollywood, right? You know, it looks kind of like this. You know, like the you know, you're like, what the hell is going on? You know, or you look at this and it's like all this text and things like that, and it's just like, you know. So the reason why we start with Scratch in this class is because it's bright and colorful, and it's actually kind of easy. Okay. So what can you do? So when the green flag is clicked, you can print something to the screen. You can think something, and that's literally the same thing as saying something, except it is a thought bubble instead of a speech bubble, right? So, yeah, it's basically identical, right? Just the difference is this one has a speech bubble, and then hello for 2 seconds, and then for 2 seconds. Do you see that? So you can click together multiple blocks, and then it just kind of just goes down the line, right? So we'll say hello for 2 seconds. We'll think hum for 2 seconds. We'll switch costume to costume 2. Hello. And then it switches costumes. So I think there's only 2 costumes for Scratch by default. Yeah, there's costume 1 and costume 2, and it's legs in a different place. So you can make a little animation of Scratch running or something. Okay. And if you just do next costume, then it'll, every time you click it, it'll switch costumes. Can it walk? You mean, I mean, it is walking, see? Or do you mean you want it to move around the screen? He's just walking very slowly. He's walking in place. Can you make your own sprite? Yeah, sure. Right here. You can upload a picture. I think there's a webcam option. You might have to do it yourself. Paint. Yeah, there's a way you can like webcam your face in and get it in there. So you can make your own sprite. Surprise! What's that? Just a random thing. And now we've got a butterfly in there. Okay. So you can upload your own. Yeah. Okay. So note when you click on the different sprite, you see how the code changes. The code is tied to the individual character. So when I click the green flag, Scratch here says hello for 2 seconds and hums for 2 seconds, but butterfly here doesn't do anything. So if we want to have the butterfly do something, we go up to events when green flag is clicked, and have it switch costumes as well. Yep. Butterfly had too much cocaine. We'll let that one drop. Okay. All right. So there's that. So somebody asked if you can move it around. It is very user friendly. Yeah, it's pretty. It's just pretty fun. And your assignment for Monday is just going to be just kind of messing around with it a little bit and sending in a screenshot of your code running. So change size by 10. Oh, that's fun. Okay. So every time you run it, it gets bigger. Size is what, 100 by default. Okay. So you can sort of you sort of have to manually reset it if you do that, right? So it just turned into Mothra, I think, right? From the Godzilla set of movies. No, it's not a Kumo. Come on, that's clearly Mothra. Come on, yeah. Mothra is like Godzilla's friend, kind of, I guess. Okay, set size to 100%. Okay, change color by 25. Fisheye. It starts warping the inside of it. Let's see, all sorts of things to play around with. It's like distorting every time. Pixelate. How do we undo that? Where do we see those effects? So we might have to just do this. Set the color to 0. Set the fisheye to 0. Set the world to 0. Set the pixelate to 0 because I've been messing with it. Just say no to drugs, kids. There we go. That's better. Okay. Alright. And then we could set the size to 100% too. And then it will keep... So every time I hit play now, it's going to reset it back to normal, right? So it stops growing every time I hit run. Hide, obviously, will hide it so that it vanishes. Exciting. And if you want to get rid of that, you have to unsnap that and then just toss it off to the left and toss it back on there. And then you can pull things off. There's different layers, like you saw that the butterfly... show, I guess. The butterfly, like which one overlaps which one. So you can do that with the layering stuff there. And that's, yeah, that's all the looks kind of stuff here. Okay. Okay, so you can play sounds. Play sound, pop until done. If you want to have more sounds, you can record one. You need your permission to use the... Trim it. Save it. Name. Raspberry. Go back over to the code tab. Your imagination's your limit, yeah. And that's really what's fun about programming. And if some of you have never programmed before in your life, maybe this will spark an interest in it. Because you can... The really cool thing about programming, and what really turned me on to programming when I was a kid, was this notion that, like, you could just have, like, in your mind, like, imagination of, like, something you want to turn into reality. And most kids, they just kind of, like, tell their parents about it. Like, my daughter, like, came up with this idea for a video game when she was, like, I don't know, 5 years old, and there's, like, air crystals and fire crystals, and like when you gather them, like they give you special powers and all this kind of stuff. And I'm like, that's cool. You should make it. She's like, what do you mean? I'm like, you know, you've seen me teaching these game development classes. You should just make it. She's like, you know, like, what? What? Really? Yeah. And when you know computer science, you can just make it. Like, if you have an idea for an animation, you can just make it. You know, instead of just having it stuck in your imagination, which, you know, if you're a creative person, like, you know, artists oftentimes say they didn't choose to be an artist. They had to be an artist because they had all this like creative, like energy that just needed to get out, you know. And computer science is a really creative field, to be perfectly honest, in a lot of ways. If you have the idea for something, you just make it, you know. So, and so my daughter actually started, like, she just kind of sit in the background when I'm teaching game development and like learning how to do stuff, and like for fun, she, like, instead of playing video games, she's like, can I play Unreal Engine? And like she built, we don't have time today, but you know, I can show you some of the stuff she built in the past. It's pretty cool. Okay. Was this about if they went to clown camp? Yes, it was. Yes, it was. Okay, so there you go. It's comedy. It's physical comedy right there. Okay. Change the pitch by 10%. Change the pitch by 30%. I don't know how much of that's coming through. I feel like I should have like some World War II like airplane on there or something. Let's see. Choose a sprite. Let's see. There's no airplane. Oh, come on. Bomber. Nah. Why would they have a bomber? Everything's so. You can't expose kids to violence. They'll. All gotta be butterflies and stuff. Have you seen the Mickey Mouse cartoons from like, you know, a while back? You know, Mickey's walking around with a gun. You know, he hears a ghost, so he immediately gets his strap, you know, off the mantle. You know. Okay, I'm gonna make my Butterfree look high when I code your assignment. Yeah. I mean, it's already there. Okay, make the volume ladder smaller. Okay, so we got that. Events. Okay, so now right now we have an event on both these guys that play when you run it. Okay, but you can also make things happen when you hit a key. So when you hit the up arrow, wouldn't it be cool if the butterfly could move upwards? I think that would be cool. So there's the motion tab up here, so we can move. So if you say move 10 steps, it's going to move in the direction it's facing. And it's facing to the right, so that doesn't make sense for up arrow, right? So let's not do that. Or we could do that and then have it rotate with the left and right arrows. That's a thing, but I was kind of thinking that for like if we wanted to have the thing move around with arrow keys, we just use these things here. So up arrow, let's try this, change Y by 10. Okay. And so let's just add an event for down arrow and left arrow and right arrow. If you guys have any questions about this, just let me know. I'm going to go back up to the motion tab. So the down arrow will change Y by -10. And the right arrow will move it to the right by 10. And the left arrow will move it left. Oop. That should be left arrow, shouldn't it? Left arrow. Move it left by 10. Okay. Now when I hit up, it moves up. When I hit down, it moves down. When I hit left, it moves left. When I hit right, it moves right. Cool. I got a video game. Okay. This lecture is your favorite film ever. Well, you know what I have to say to that. Okay. So, Yeah. And then if I hit space, I'll glide to a random position. How about that? So when the space key is pressed, it will glide to a random position. How about that? Okay. And notice the thing's not even running right now, right? Like these things work even if the thing hasn't hit run. That's why I said there's a couple different ways you can set up your Scratch project. What the hell, Bobby? Yeah, so you could make your thing do things when you hit run, or you can just have it do like when you hit the arrow keys, it does things. Either way. When the sprite is clicked, yeah, that's another thing you can do. When the sprite is clicked, change the color by 25. Kind of cool. Hallucinogenic butterfly there. Okay. Is Butterfree the final form of Venonat? Or is there one after that? Okay. And then, let's see. Yeah, then we got our loops here. We got our conditionals. We got our loops. We got variables. And we're running out of time, so we'll probably just pick this up again on Monday. For now, we'll just do motion stuff. Let's see. Start as a clone. Delete this clone. Stop all. Let's see. It's clicked. Yeah, I think maybe we'll just stop here and just talk about backgrounds, maybe. Touching another sprite, yeah. Yeah, let's do conditionals, I guess. Okay, so so when the thing is clicked, it's doing all this stuff, right? Then what we want to do is say forever. That'll go into an infinite loop. So if we do forever, for example, play a sound. That's an infinite. That's a hell of an infinite loop right there. Let's do play sound until done. So it doesn't, because it was immediately every frame it was trying to play it was restarting the sound every frame. So we want to play the sound until it's done. Then it waits, right? Okay, you get the idea. And then let's add a conditional. So this is a loop. So it's a forever loop. It runs forever. It'll never stop until you hit stop. And the webcomics that I got, Penny Arcade, Order the Stick, Dilbert, Something Positive, XKCD are my main ones that I read. Okay, so is this going to be today's assignment? Yeah, this is going to be today's assignment. You just screenshot it, attach it on Canvas. So let's do a conditional too. So there's different loops. You can have something happen 10 times. And the way that they work is you just kind of stick them on, and you notice you can't attach anything to forever because forever never ends, right? But if you had something happen like 10 times, then you could have something happen after it. Well, let's do a conditional. So we're gonna say if something, then do something. And so what I want to say is that if Butterfree here. We gotta change that name to Butterfree. Don't sue me, Nintendo, please. The farting butterfly. Hallucinogenic butterfly. If it ever touches Scratch, we want it to eat Scratch, because it's Mothra, right? And let's change its size by 300. Okay. Maybe it's a little too much. Like, I'll start over here. Then we wanted to say if it ever touches Scratch here, kill Scratch. Okay, so there's a little diamond, rhomboid, I don't know, a hexagon shape there. And what goes in there is these things under sensing. And so you can sense things like, is the mouse clicked? Is it touching a certain color? Is it touching a sprite? Is it touching the mouse? When are people going to get creative? Chris Pratt as Mario? Okay, I might need to see that then. This going on YouTube? Yeah. Wait for the wait for the copyright takedown. Okay. Okay. So what we want is to say if we touch Scratch. If color's touching this, if we're touching, here we go. If we are touching Sprite 1, and Sprite 1 we're going to rename to be Scratch. That's the name of the cat. Oh, shoot. No, that's not right. Name here. Scratch. And this one is going to be called Butterfree, please don't sue me. Okay. It's the name of the... It's not Butterfree, it's Butterfree, please don't sue me. Okay. So if we're touching Scratch, then what? Then we are going to... let's see here. Drag that in now. Then we want to erase Scratch. Might be a little bit too optimistic right now. Without doing variables. Yeah, maybe we'll just put that off to the next class. We got 3 minutes left. So we do it the other way around. Scratch, forever. Forever. Scratch. If sensing, touching, Butterfree, please don't sue me. Then looks, hide. And then we'll play a sound to play a sound until done. And the sound we're going to play is going to be the Wilhelm scream. More or less. If you guys haven't heard of the Wilhelm scream before, it's used all throughout movies and video games and things like that. You can watch compilations on YouTube of it. So we're going to play Wilhelm scream, and there we go. So running, and I can move you around, and then Mothra eats Scratch. Okay. Now if I try running the project again, it's gone, right? Because these things are, like, the workspace is actually permanent. So one thing you have to do when you're doing Scratch is just reset everything, like when you run it. So like here under the green flag click thing here, we always want to start off by showing Scratch. Okay. Okay. And then the next time we run it, he reappears because it re-shows. So if there's anything you're doing, like rotating the colors or changing the costumes or changing the size, when the first thing you want to do under when green flag clicked is to just reset everything. Okay, so that's our lecture for today. So you're basically going to do this. Have fun with it. Just make a little interactive thing where you can use the arrow keys to move a thing around, and when it touches something, do something. I'm going to leave it fairly vague and unspecific. You can make a bowling game where, like, you control the bowling ball with the arrow key. When it touches a pin, it deletes it and you go, or something like that. Just have fun. And post your project onto Discord. Share it with other people. Have fun with it. This is not a murderous homework assignment. Okay. So, just screenshot your project and just link it on Canvas. That's how you'll get your grade. But it should be fun for you. Murderous. Yeah. You want to use the Godzilla atomic breath charging noise? Yeah. Have you ever seen the background on my profile on Discord? It's Godzilla. So, about to build Skynet in Scratch. That'd be the best thing for humanity. Skynet would run so slowly. It's like, die humans. Be amazing. Okay. Any questions? Do we screenshot it? Yeah, so on Canvas, you'll upload a file, and the file you upload is just a screenshot of your Scratch project. I want to see this part here and this part over here, basically. So, okay. Just have fun with it. Don't, put 50 hours in on this project, because it's literally just can you use Scratch? Okay. All of you should be signed up on Scratch already. That was one of the initial steps here. Join the Scratch class. That's how you sign up for it. So hopefully you've already done that. But if you haven't, you can just literally go to scratch.mit.edu and click on create, and then you can just make something real fast. Okay, can't stop you all. All right, I mean, if you want to spend 50 hours on this, knock yourself out. Okay, don't stop me now. We're having such a good time. Nice Queen reference. If you have multiple sprites, would you have to send multiple screenshots? Yeah. Screenshot that, or whatever, or not. Just screenshot one of them. I don't. If show me the main one. I really don't care. Okay, I'm not. Again, this is not supposed to be punitive, right? Just show me that you've done something. That's it. You get an A. All right. How do you join Anonymous? Okay. All right. So, hope you all have fun with this over the weekend. And if you have any questions, just ask in the Help Center. All right. See you guys on Monday.